Hello! In this module, we're going to be adding some motion to our robot with some motors and the help of a dual H-bridge microchip. Dual H-bridge microchips make it a lot easier to work with motors in circuits. They handle power and speed and going back and forth. So here are the ingredients we're going to need for this module. We're going to need a completed quick start, which is right over here. I assume you've already done the quick start module. If you have not done the button and LED quick start, go back and do that first. We're going to need something that we want to spin. What I've done here is I've assembled some primitive cardboard wheels attached to like the gear or the little paddle for the motor with some zip ties. Depending on the motor you're using, you might use a different kind of gear to attach it. The paddles work for the motors in the little blue boxes. For the ones with just the regular shaft, use one of the white gears. We're going to need a motor of some kind, of course, because that's the thing that actually spins. There are two motors that I bring to all of my workshops. I bring the standard simple hobby motor, which is great for spinning things super fast. And then I bring a smaller motor that's in a servo casing that has been geared down so it spins slower, but is capable of more torque at lower speeds. And I'll be using these in the rest of this tutorial. We need a dual H-bridge chip, which is the chip right here. It comes in a little bag labeled dual H-bridge. I've gone ahead and I've pre-wired some of it so that we can move through this module a little bit faster. You're going to need a ton of jumper wire. As you can see, there's a ton of jumper wire here. And finally, you'll need a power source of about 5 to 6 volts that is not the pins on the Arduino board. You're going to need some kind of external power source. Here, I'm using 4 AAAs in series, but you can also use like a USB power bank to supply this power. So let's go ahead and get moving. Like the rest of our tutorials, we're going to be copying stuff from Johnny 5. So first thing you're going to do is copy this circuit down. It has lots of wires in it, but most of them are just ground and voltage, the power. And I've gone ahead and I've done this ahead of time on this board so that we can move a little bit faster. I've done it on a separate breadboard because you might need more space. So go ahead and grab a bigger one or a different one if you're doing motors. And all I've done here is the ground and power. So here the power is the yellow and purple wires are 5 volt for power, and the blue wires are ground. And I've just copied them over to these pins and the outermost pins on the 4 corners for power. And my wiring is a little different, but it's the same basic idea. So let's wire these up the rest of the way. We're going to add ground and power to these circuits. So one place I want to bring ground in, on this pin right here. I'll use a green wire for that. And I'm going to bring it in from a different ground pin on my Arduino. And for power, I already have a 5 volt line coming into my quick start. So I'm just going to bring it in from over there. So I'm going to take a red wire and I'm going to put it in that channel. And I'm going to copy it over here. So now I'm delivering power up here. But right now I'm just powering it off of the Arduino. So what we want to do is in parallel, we want to add our own voltage source. I have this off right now. One is on, one is off, but they're in series. So that's the switch I'm going to use to enable or disable this. And I will wait until my circuit is ready to go before I'm going to turn it on. So in this case, my power is the bottom wire and ground is above it. So I'm going to plug that in right there. And we can ignore the batteries for now. Great. Okay, so that covers power and ground with the additional power supply for our circuit. Now let's wire up the Arduino. For each motor, there are 2 pins. There's one pin shown by the purple wires here, which is the direction. So it's a digital pin. If it's up or down, will determine which way the motors spin. Then there's another pin which comes from a PWM pin, kind of like an analog out, that tells the motor how fast to spin. It's using pins 11 and 5 on here with the orange wire. So we do not have the conflict on those pins, so we don't need to change them. So we'll just use the same pins in the example. Now I'll use red and green wires to signify these. I'll use red for the direction and green for the speed. So let's copy over to the two closest to the top of the chip near the notch. We're going to copy pins 12 and 4. Go ahead and do that. So pin 12, you kind of route it around. We have enough wires that routing is starting to become an interesting challenge. And it is the second from the top. Top signified by that little notch. Next, we're going to need to copy from pin 4 all the way up to the top of the other side. This one might be a little bit of a tight fit. Yeah, I'm actually gonna have to grab different wire. I'll just make it reach. Not quite reach. I will use a green wire on this side because they're a little bit longer. This one is also doing the direction. I'm actually going to change this red one so that they match. So green is the direction and red is the speed. This was pin 12. We're going to go to pin 12. I've knocked that ground wire out. Let me put that back in. A nice firm ground connection is very important. The next pin 5 is going to go to this side of the chip, the right side of the chip, and pin 11 will go to the second pin from the bottom on the left side of the chip. We're going to go to pin 5 and down in there. It's a little bit of a tight fit, but it makes it. And then pin 11, we'll go over to second from the bottom here. And now we get to do the fun part. We get to hook up our motors. So I've gone ahead and already hooked up one motor to a cardboard wheel. I'm going to attach this one. So it's using one of these paddles, and you got to push kind of hard on that to get it to fit in there. You can use a screw to hold it down if you need a little more security. I'll just leave that one pressure fit. And then we want to attach the motors and the servos. So these have little connectors that are female, so we're going to have to use some jumper wires to wire them in. I use the green wire on the not red line and a red wire on the red one. Great. Okay, so let's wire them in. So you can tell that the wires in the diagram are green and yellow, but all that's important is that they're reversed. So we'll use red on the top of one side and red on the bottom of the other. And this is the third pin back. So there, and getting a little snug, and there. And we'll see if we can force that one into staying on camera. And then on this side, we will be using the red pin on the bottom, the third pin from the bottom, and the green one, third pin from the top. And those are our wheels, and we'll see if they stay in place. Let me get that power supply a little out of the way. Let me bend these wires a little bit so the motors both stay photogenic. And so one thing I like to do now is just run the program that I knew was working before. So I'm gonna plug it in, and I'm not gonna spin the motor. So I won't turn on the external power supply, and I'm just gonna run the quick start code to make sure that it still works. We're going ahead, basically making sure I didn't break anything terribly, like shorting out the board or something like that, and it still works. So when I push the button down, the LED still turns on, which is great. So now we can go and we can copy some of this code into our program. So I'm gonna make a new file. I'm gonna take the quick start and I'm gonna copy it into a new file, which I'll call index, and save it. And what are the things I want? So first, I want the motors. So the motors, one of the cool things about Johnny 5's H-bridge stuff is you can have multiple motors in an array and then talk to them like they're a single motor. So here's an array of 2 motors. We have the first motor and the second motor, pins 12 and 11, 4 and 5. Double check there are no conflicts. Looks good. We want to add it to our REPL so we can play with it from the REPL. And then we want to spin the motor. So let's just go ahead and copy just one of these, the full speed forward and full speed backwards, and we'll play with it from the REPL. So let's go ahead and run this. Oh yeah, we turn on our external power source. This is just, in this case, a little switch on that battery box. Or I might plug in the USB battery if I'm using that. We'll go ahead and run it. We'll see if these little, you can see they're spinning. And if these were on opposite sides, lined up the same way, they would be spinning full speed forward. They're dancing around a little bit. And we can interact with them from the REPL. We can stop them. We can make them go reverse. We can change their speed, which is going to be some value between 0 and 255. But one thing you'll find is that all motors have a stall speed. Below this, below this signal, they're not going to have enough torque to be able to turn at all. So if I give it 50, that one's it can move a little bit faster, but they're both below their stall speed. They're stalling out right now. You don't want to leave them running at below their stall speed for very long, or they get grumpy. Oh, did I kill it? Let's stop them and try starting it up again. Oh, it jammed itself, it tangled itself up in the wire. So we've gone forward and backwards. What about turning? So turning, building like a steering column like you'd find in an automobile is actually quite hard. The easiest way to get robots to turn is to do steering more like a tank, where to turn left or right, you stop one motor and spin one motor. So I could do motors 0 dot forward. I could make it turn slowly that way. So it's kind of like a creeping turn. Or if I want to make it turn really fast, like stop in place and spin around, I take the other motor and make it go reverse. So that's how I'd make the tank kind of spin in place as fast as I could. I can also stop them. So that is kind of a basic moving around with motors for locomotion. You can use the same H-bridge to do other components on your robot, like spinning weapons and things like that. That is the end of this module. So thanks a lot for watching. Go ahead and jump into a different one.